Good afternoon, everyone, and welcome. This is one of our fun classes. We're doing a Raspberry Pi project and everything. Let me introduce myself if you haven't been in one of my previous classes. My name is Alex Cooper. I teach the computer classes for the Columbia County Library in Evans, Georgia, also the Harlem Library and the Uchi Creek, now Grovetown Library, because we have a new building in Grovetown, so yay. welcome. And I have my Halloween shirt on today. I'm actually wearing a Charlie Brown and the Gang, and it's a really neat Halloween shirt. And this is kind of a neat thing. We usually don't do special Halloween classes and stuff, spooky themed and everything, but we are doing a course this month because we're kind of staying home, staying safe and everything. And today's project is we're going to be doing a Raspberry Pi project, how to make a sound trap. So the idea of this is we actually have a class that we do a whoopee cushion in. Okay, so we make a funny whoopee cushion. Someone sits on it and it makes a kind of noise. The company that makes Raspberry Pis are British, so I think that's very humorous. And we always get a good kick out of it, and also the kids. We make the whoopee cushions out of paper plates too, so we're kind of doing something similar to that, but we're flipping it around so that we're going to make it a sound trap. So if someone steps on it, we can put it at the front door, have it like underneath a mat or something, and then when someone steps on the mat, it'll make some spooky sounds. Okay, so we'll choose which spooky sounds we want to use. Unlike something that we buy at the store or whatever, we can make choices about what we want it to play, what we want it to do. And then we're also going to show you how to wire it up with our Raspberry Pi, and we'll also make one of our sound traps out of some paper plates and tinfoil and glue. Okay, so be ready for that. So welcome. And I also will turn our other camera on in a little bit here, but let's go ahead and let's get started. Just kind of let everybody know, feel free to kind of post questions at any time. I'm definitely happy to help in any way I can. And I also will provide links to the everything I'm going to be doing basically. And I also have a handout that I'll be posting as well. So have any questions, feel free to post them in the chat. It may take me a minute or two to get to them. This is just kind of a list of some of the other stuff that we have coming up that is previously. The rest of this week we'll have a new schedule coming out soon. For next month we might have some Thanksgiving themed classes as well. Maybe a drawing and animation scratch class would be a lot of fun. So earlier this week we did a Unity class. All these classes are still up and available on the YouTube channel that we're on right now. This morning we did the Halloween Python coding spot the difference prank, and we also tomorrow we're going to be doing a gadget help with Zoom with me, Alex, for the Grovetown Library. Just call into the Grovetown Library and set your time. It'll be 30-minute or 60-minute increments, and they'll give you information about that. And then tomorrow afternoon we're going to be doing a Scratch Basics class. Let's make a spooky game. So we're going to be making a neat spooky game with the ghosts and everything, and it's going to have a counter and everything. Just a little side note to let you know that our libraries are open with limited services and hours, and curbside holds pickup is available. You can go to gchrl.org for details, or you can call into the library Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. Right now we're having a subscribe drive to see if we can get 100 subscribers to our YouTube channel, we can get our own customized YouTube address. Or search YouTube for GCHRL videos and we'll pop right up. All right, so let me go ahead. I'm going to post my handout. Just give me 1 second. Any questions so far? So let me go ahead and post this. Usually what I do is so that you guys can follow along with me is I have a handout in class, something that you can print out. And then we can kind of do it on the screen. And then also you can do it in front of the computer in front of you. So Raspberry Cloud classes are very popular. All right, so here's our handout. All right, so let me go ahead and open that. We'll kind of be on the same page. Now I've revised this from the whoopee cushion, so that it may say whoopee cushion in here a few times. So just be aware of that, because we do actually follow along with kind of the same setup and everything, but we're going to make our sounds different, of course. So welcome to class, and of course I'll disappear when we actually get into some main stuff here. So we'll actually be going to be coding in Python on our Raspberry Pi. And let me go ahead and get that started. Make sure that that's all connected and stuff. All right, one second, I gotta find it. It's right here, and then I'm looking for something. Oh, there it is. I always think it starts with a V, but it's called Real VNC. All right, yay. All right, so basically I have the Raspberry Pi in front of me, which I'll turn the camera on in a little bit, but also I can control the Raspberry Pi here. So don't let this throw you. This is just a visualization of the Raspberry Pi so I can work on it and we can code for it and everything, okay? All right, so let's go ahead and let's talk about our Halloween project we're going to be doing. We're going to be making a Raspberry Pi doormat or door trap or whichever you want to call it. I kind of thought the door trap would be kind of interesting, but I just want to make sure that we're not actually going to be, trapping anybody, because I saw a sign that says the door trap here. But it's just something funny. They step on it, it makes a sound. So let's talk about what we're going to need, and I'm going to disappear. And like I said, this handout is in the chat there so that you can download it and walk through everything that I'm doing too. Now, my handout and the one out Raspberry Pi, I do have Raspberry Pi 4, but Raspberry Pi, all the Raspberry Pis, to my understanding, you can do this with the same project, because it's just some Python coding and it's nothing really intensive or anything. And it actually has the same Gpio pins, which we're about to talk about that. So I'm kind of talking to you like you had just purchased the Raspberry Pi, came to class, wanted to do the projects with us, and I said, that's great, it's awesome, let's do it. So first you need a Raspberry Pi. What do you need? Raspberry Pi, you need at least a 8 GB memory card. Of course, the bigger the better, kind of recommended. Raspberry Pi, the base price of it is $35. Of course, you may want to get one that has a kit that comes with the power supply and stuff, which I recommend. Having a monitor, having something like a US keyboard and mouse plugged into it, and of course we won't need the breadboard today, and we won't be doing the LEDs and stuff like that today, but you will need a female male jumper on there, female to male. Okay, it's female to male is what you actually need. And some alligator clips. Okay, and a little bit I'll go through what we need to actually do our Raspberry Pi. Okay. All right, so let's go ahead and let's get started with Python a little bit. And then we'll talk about Gpio pins on our Raspberry Pi, hooking that up, and then we'll get together and we'll actually get our Pi plates all taped up and everything. And I was thinking there's probably a different way that you could do this, as long as you can basically get two pieces of tin foil to not touch and then touch each other, then basically complete the circuit. Then you can actually complete this in any way. Okay. So I even thought about it like a piece of cardboard. To be able to do it that way, whichever you wanted to do, just as long as it completes the circuit and creates a button. So let's go ahead and let's get started here. Computers need instructions to be of any use. Without instructions, they are just expensive, or in Raspberry Pi's, inexpensive lumps of plastic and metal. We can write these instructions using a programming language. One of the easiest text-based languages to learn is Python. Just because Python is easy to learn does not mean it isn't powerful, however. So one of the things that we need to do is, and I actually recommend using mu, and I actually have let me pull that up. Give me 1 second, let me find that. Now there is a basic program, the Raspberry Pi, not Raspberry Pi, but the Python that you can do. But the newest one that's kind of come out is mu. And let me show you that real quick. So this is the link I just put into the chat. And the big thing about this is it actually goes through, mu is a new program that you can use. And it actually has, Python, of course. You can download Python 3. But it's a little bit easier to use. It already has some things built in like Pi game and stuff like that. So if you do some other projects, it's already in there and you don't have to do any separate installation or anything of add-ons or different libraries. And it's kind of easy to use. And this is kind of what the Raspberry Pi is really starting to switch over to. So if you have the latest version of the operating system for the Raspberry Pi, it'll actually have mu built in already. And basically, like I said, it comes with it. But our project today is on the Raspberry Pi, so you can't really download this for Windows because everything we do is going to have to be on the Raspberry Pi. But it's pretty easy to use, and you'll kind of get to see us use it back and forth. But if you're interested, you can. It does come with a version that you can install in Windows too. Okay, so let's go ahead, and I'm actually going to. So this is our Raspberry Pi, okay, and if I can switch over here. Hold on. Hold on 1 second. So it's the classic, everything works great until it doesn't. Okay, there we go. Hello. Let me turn it a little bit here so it's a little bit better on my table. There we go. Let me move that a little bit over too. Okay, so yay, you can see my hand and stuff. I'm actually going to move it down to the bottom right down here. I won't have this on all the time, just to kind of show you what I'm working with. So here's our little Raspberry Pi. We also have our alligator clips. And let me go ahead and get the male-female cables. All right. We just need 2 of those. Let's see. All right. Box of goodies for other projects. Did a doorbell one earlier this month, which was pretty fun. Okay, so here's our here's our Raspberry Pi right here. I've connected to it wirelessly so we can control it, and we can also do our projects on it as well. Now this is usually what we have with our breadboard, but we're not actually going to connect directly to it today, so we actually won't need that. Okay. Now I'm going to go ahead and let's start Mu. So we're going to click the Raspberry Pi button, programming, Mu. Now it may ask you if you start something new, which, and I'll close it because it's got a file open already, which one you want to open. So let's go ahead and let's do our first project here. And I'm going to turn off that for now. Let's go and keep talking here. So the Raspberry Pi, like I said, these instructions are actually for the Raspberry Pi 3 program, which we are encoding in 3, but we're actually going to be using the Mu today. So that actually gets started. So instead of Python 3, say Mu. Okay. Now the difference between this and our regular Python shell that you could actually download and install, you can actually go to it doesn't do the main at all. It has it set up so that in the regular Python you actually have a shell that you put things in like this, and then you actually have an extra window that opens up where you can save stuff. In Mu, we actually can do that in one window. We don't have to keep fighting with 2 windows, and it has nice little tabs that go back and forth as well. Okay, so let's go ahead and let's do the classic print hello world to make sure everything's working right. So we're going to type here print, meaning put something on the screen, and you will see that it tries to help us a little bit, and it'll even give you certain sections or suggestions. So we're going to do quote, I am writing Python. That's kind of the classic hello world. Now we cannot run any files unless we save them. Let's go ahead and hit save. Say what do I want to save them as. Now this will be very important later, because when we put our sound files on our flash drive and move them over to our Raspberry Pi, we'll actually need to make sure that they're in the same folder, or same folder as our file is. Okay, so we're just going to go ahead and call this doormat because we're going to use this same file. We're just going to make changes to it, okay? All right, now when I hit run, you'll see it opens up below here and runs our code. There we go. I am writing Python, okay? I hit stop at the end. Now, used to, we'd have to do a keyboard command, Control C, and you'll still see that on my handout as well. But we will not have to do that because it actually we just won't have to do that because mu doesn't work that way. All right, so let's go ahead, go to our next page. Let's talk about our GPIO pins on our Raspberry Pi. Okay, one powerful feature of the Raspberry Pi is the row of GPIO pins along the top edge of the board. GPIO stands for General Purpose Input Output. Repeat after me. General Purpose Input Output. General Purpose Input Output. These pins are a physical interface between the Raspberry Pi and the outside world. As the simplest level, you can think of them as switches that you can turn on and off in the Raspberry Pi, okay, with software. The GPIO, General Purpose Input Output, pins allow the Raspberry Pi to control and monitor the outside world by being connected to electronic circuits. The Pi is able to control LEDs, turn them on or turn them off, run motors, many other things. It's also able to detect whether a switch has been pressed, the temperature, and light. We refer to this as physical computing. Okay. There are 40 pins on the Raspberry Pi, 26 pins of earlier models. They provide various different functions. Okay. If you have a Raspberry Pi operating system or labeler, a Raspberry Pi labeler, it can help identify what each pin is used for. In class, I actually have one, but I'll just use the little handy chart that I have. And I also have a chart. Of course, we're about to scroll down, and you can see that below as well. But I have a little handy chart that labels them for me. You can identify them by the pin number: 3V3, 3 volts by 3.3 volts, 5 volts, ground, or GP, general purpose, pin 2. So anytime we see something that says GP, whatever the number is, that means that's that pin. So let's look at our little chart here. So if we're holding our Raspberry Pi with the USB ports pointing down, okay. Now, in class, I actually have one of these, but currently I don't have one with me. But all I have to do is look back here at the chart, okay. The big one is, there's 3 volts of power here. There's 5 volts, GP2, GP3, and ground, okay. GP4, GP14, and so forth. Anything that can connect to power has to, the other one side has to be connected to ground. Everything that we connect to, like a general purpose, then we have to have the other one connect to the ground to complete the circuit. Okay, so we're going to talk about completing the circuit in just a second. So let's talk about input and output. Using the GPIO pins on the Raspberry Pi, it's easy to send a signal to an output component and turn it on or off. You can also detect whether an input component is on or off quite easily. Components that operate in this way are called digital components. The cell provides provides energy to the circuit in the form of electricity. A cell has a positive and negative side. Electric currents flow from the positive side of the cell to the negative side of the cell. There's a little bit of dispute about that lately, but we're still using that, so don't worry about that. An LED diode is a component that only lets current flow through it one direction through it. Okay, So basically, here's our circuit, long leg, short leg. Electricity is flowing this way. It gets to the resistor, or kind of like a fuse, so it doesn't let too much electricity through. And a button that we press is similar to this or a switch. If it's closed, the electricity flows back to the ground. Okay, so positive to negative, positive to negative. Now when the circuit's open, meaning the button is not pressed or switch is open, it gets here and it stops, and it doesn't complete the circuit, so it doesn't light up the LED or the light bulb. Okay. Now we will not be using a breadboard today, so we won't talk about that. So let's go ahead and let's talk about hooking up our project, and then we'll actually make our paper plate. Okay, and then we'll do our coding. Now, like I said, this is similar to the Raspberry Pi project, so if anything in the handout here still says whoopee cushion, I think I saw one thing I did make a change to it. All right, building a Pi-powered doormat, aka make your own button, is kind of what this is like. Thanks to the Raspberry Pi, you can add whatever noises you want. Tape or stick circles of foil into the cardboard. There are your contacts. When you touch, they will complete a circuit. Just like I was saying, you could do this different ways if you wanted to have a different kind of doormat, as long as you have it where it's 2 pieces of tin foil, and when someone steps on the mat, it closes, and then of course you want it to reopen again so they can step on the mat again. Okay, because we're going to make it do 3 sounds. Okay, using some copper tape, connect the foil to the edges of the plate. Chop up some sponges, which we're about to do, into cuboid chunks, and glue them around the foil on one side of the plate. This will stop the foil squares from touching each other until someone sits on the plate, or stands. We'll change that to stands. Stands on the plate. It should look something like this. Okay. So let's go ahead and we're going to actually put our paper plate together. All right, so let me turn my camera on. Yay! All right, get my box of goodies. Our box of goodies. All right, so we've got our sponges. We've got our plates in here. We've got our tin foil. We also have our glue sticks. Okay, so let's get what we need together. Here's a glue stick. I already got a tin foil open. I think that one's already open. We got our scissors. And I got extra glue stick just in case. And should have some tape. And I'm just going to use one sponge. And we need to get our alligator clips. And it doesn't matter which color. We got our alligator clips. These are great for projects. Okay, so put our stuff together. So we need 2 plates. We also need to cut up our sponge. And I'm actually going to cut off this part here. Ugh, still a good sponge to use. Mostly, what do we want the sponge for? We want the sponge so that it pushes back. So when actually someone steps on it or sits on it or whatever our project is. And I think I'll cut it up into 4. Okay, we're done with our scissors. Okay, let's get our tape started. Awesome, Rachel. All right, so let's see. Okay, so let me get my, so we want 2 on one side and 2 on the other. And we want to get our glue stick. It's a very inexpensive little project. Let's get our glue stick. We want to do it kind of everywhere in here, because this is where we're going to put our tin foil. Okay. And because of the camera, I guess I'll just do, you know, each side separately here. Let's get our tin foil. And this is a special tin foil. It's a pop-up sheets. I found this to be really great for these projects. And go ahead, and the idea is I actually want to put like a tongue sticking out on one side, okay? So I actually want it to push down. And you can kind of bend it all in here, so, or you could tear your tin foil if you want to. Maybe I'll tear it, because I don't want it to stick out too much here. I think I could use one of these on both of them. And you want to have it so, and I kind of call it like the tongue, like it's going to stick its tongue out. Okay. All right, like that. So I'm going to go ahead and make 2 of those. Well, I think I could go ahead and do the, I might glue this part down. I don't want that to stick up too much. Okay, so it's flat, and I kind of want to put some glue up here too. All right, now go ahead and do it so we can have our, and I'm going to do it so it's kind of like here, and there's the tongue, so I'll do this side here, okay. Put your glue down, and then glue your sponge, the glue down, the sponge. It's just got to kind of hold it in place a little bit. Let me move my microphone a little closer. Is that a little better? Okay, and then go, and right about here make another one of those. We don't need to do the sponges, of course. So this is kind of like when we merge coding with arts and crafts. Okay, now I'm going to have it so the tongue kind of up there, and kind of have it down there, and kind of fold this over, just so it's nice and flat. You don't want it to stick up and accidentally they touch at the same time. And glue that part. And share this class because this is the only class that we do this this part. So okay, so the idea is that we're going to get our alligator clips. Make sure this part's sticking out a little bit. There we go. The interesting thing is on their website, of course, it's instructions for the whoopee cushion, but on their website they actually have it where they talk about double-sided sticky copper, which is interesting. So here's one of the big ones here. So we have like the tongue sticking out, okay, and we want to make sure everything else is flat. So we take our alligator clip and we're going to clip it to right there, okay. Now, let's get our other one. Whoop. And I had two sponges that just fell off, so give me a second. They just went flying. I picked it up and it went, woo! We're out of here. So maybe my glue isn't that great, or maybe my sponges are too absorbent. Let's see. Now, you don't have to do the sponges, but I will tell you this. When a person stands on it or sits on it for 1 second, it will not work anymore. Okay? So make sure you put the sponges in there, or however you're going to do it. Like I was saying, I was thinking about, you could actually do it where it's like a piece of a cardboard or something, and if it was just like a little bit, you put the piece of foil here, and you have the one alligator clip here, one here, and then you barely have it under the mat, and when they step, it just moves barely. It's all you got. I just need that much of movement. Not much movement at all. All right, so let's get our alligator clip. And, oh, come on. Come on. It's trying. Okay, so there's my alligator clip. All right, we hook it onto our part here, and I actually don't need it to be that much up there, so I may make it a little bit smaller. Like I said, it's kind of like a tongue sticking up. All right, now here's the clincher here. I think, did I do the glue on this one already? It's hopefully when we push it down a little bit, the sponges will stick to it. This is always fun because I'll get little bits that want to do this part. Now here's the clincher. You got to make sure that the two pieces are not touching because that closes our circuit. What we actually want is it to be, and usually about there is fine, okay? So just to make sure that the alligator clip's touching this tongue side and that's touching that tongue side, and none of the the aluminum is touching anything else. So this might have a little bit too much, so I'm going to push that in a little more here. Just make sure the aluminum does not touch unless it's being pushed down. Okay, so I'll have it. I mean, you could go way, I don't think you'll have to go that extreme, but if you can just have it so just right about there. Now, the plan is now we're going to use our tape. Put the glue top back on. Use our tape. To close it up. So and cheap tape. All right. And just kind of go around. It doesn't have to be too intense, I guess. You know, if you don't want this to scare anybody, you could maybe even draw or paint on the bottom of it. You know, step on me or something like that. Step here. And then when they see it, they'll be like, oh, I want to step on that. Or I'm supposed to step on that, and it won't scare them, but then they're part of it because then they're controlling it. So all kinds of crafty ways that you could make it a button, so when someone pushes on it, it closes the circuit. Okay, so someone comes pushes on it, it'll actually still kind of pop back up. Okay, at least enough so that it's not touching. All right, so let's set that away. We'll bring that back in a minute. And let's bring our Raspberry Pi back in. Hey, little Raspberry Pi. He says, did you miss me? Sure, we missed you. Okay, so the Raspberry Pi, and it's really not a good idea to connect to our pins with our alligator clips because that could bend or damage. So that's why we actually have the proper pin. So it's the female, and then we have our male. So then we'll actually connect the male alligator clips. Now what we do in class when we're doing the whoopee cushion, we actually use 2 alligator clips linked. So we'll connect the 2 alligator clips together to make it longer cord. Yeah, so all right, so let me go ahead and now let's do our coding part. All right, now. Oh, and the full address is here for the whole whoopee cushion and blog and everything like that, okay? Yeah, so they have, you know, like copper double-sided tape. That was pretty interesting. And one of those, you know, pulling that out, and I was like, I haven't seen that ever. But then it was like, oh, but you can use sticky glue. It's like, okay. So you could technically use double-sided tape or something, but just remember, if you don't put a sponge in there, it doesn't actually come back or pop back up, which is a little bit sad, okay? It's been squooshed. Okay, so let's talk about connecting our doormat to our Raspberry Pi, okay? And I'll read this and then we'll pull it up. The big thing is we need to have it connected. We're going to connect to the GP2, which is the second on the bottom left, okay? And the third on the not bottom left, but the third on, it's the second on the left and third on the right, okay? This is a button. It does not matter which one you plug it into, okay? It will not matter. But we do want to make sure that it's grounded, which the ground is doing here. So the ground has to be there to close the circuit, okay? So let me go ahead and I'll switch on my camera. Yay, I'm back. Okay. So the easiest way to do this is just kind of realize you need to hold and see if I can. The power supply is pulling on it. Okay, so I guess I'll just hold it. Okay, there we go. All right, so having our power, our USB pointed down, okay, and we can see our graph right here. The neat part is you can even see the little screw hole here for screwing it into like a case or something, okay. So I got my male female. Well, like I said, it does not matter which one you plug it into, but we need the second, which is general purpose 2, and then the third on the right. So when you hold that up, you should see second on the left, third on the right, okay. And then we'll just hook our alligator clips to that, but I'm actually going to touch those so we can, when we get our exercise, so we know it's working, okay. And get something to hold the wire so it's not moving around. There we go. Okay. All right, so that should stay there now. Okay, so let's go on and let's do our coding. So in class, I have like a whole bunch of little bit. I'll even have some that will want to make the whoopee cushion thing. And then I'll say, okay, now we're going to take turns and sit on it, which you'll see at the end. And then like, I don't want to sit on it. It's like, okay. I've even had some that take it home with them. You know, they're like, oh, you can keep that if you want. Yay. And it's like, I don't know what you'll do with it unless you have a Raspberry Pi at home. But anyway, it's still fun. It's still fun to make stuff. Okay, so their example here, they're actually showing alligator clips. Alligator clips here, and I'm not sure what those are called, but the whole paper, a whole stack of paper together. Those there. But of course we use tape, so you could get real creative. Like I said, anything that will make anything that you have that keeps the pieces of tinfoil together, or the wires, and then brings them together to touch, closing the circuit, it'll be fine. So you could actually get creative. All right, so let's talk about creating our program. Okay. All right, so it has way that you could search for spooky sounds. I already have some spooky sounds saved, and we'll actually copy those over. I'll play a few of those, and we can choose which one we want. And then we'll need to save those and copy them over, and then we'll actually start doing our coding. Okay, so let me go ahead and I will open where I saved the sounds. Ooh, Halloween sounds. And I can actually post these into the chat too. So I think I heard some favorite ones of mine. Hopefully this won't be too loud when I play them. But anyway. And I'm going to rename some of these because it gets a little ridiculous. Here's like thunder. Bats. effects, so these are all supposed to be non-copywritten.
Happy Halloween. Leave now while you still can.
Leave now before Master finds you.
Who is that knocking at my door? Who is that knocking at my door?
It's cute, but I think it's too long. Let's see. Let's see. Terrible. All right, so let's see. Kind of like the bats. I need to rename this one. I'll call it bats. Okay. See about kind of like the ghosts. Has a little bit of everything in it. What about I think that sounds good. All right, so let's do bat, haunted house, laugh with the howl. Sounds like those kind of go together properly. All right, so I'm going to put in my flash drive. And we're going to copy those over. So bats, haunted house, and laugh howl. Okay. Okay. Now, let's go ahead and I need to bring back up our Raspberry Pi. And let's plug it in our flash drive in our Raspberry Pi. There's our neat sounds. I'm going to copy those. And this might be the tricky part. I have to make sure I have them in the folder. Let's see. That Muse, there it is. Okay, good. So it's Home, Pi, Muse code. And I can see the doorbell right there. And I'm going to do edit paste. So I did copy paste. Okay. And if oh, it won't do any good. I don't have it plugged into any sound. So let me go ahead and do that now. So now you could have done the drag and drop, of course, putting the files there, but you have to make sure that they are here into the mu code in the same place that you saved your original file. Okay. Now, go ahead and turn the thing on here. All right, so I'm now done with the flash drive, so I'm going to take it out. And I actually have
Bluetooth mode. Bluetooth is connected.
a code in the same.
Power off.
All right, so
Bluetooth mode. Bluetooth is connected. 80%.
okay. All right. How's that?
Line in mode.
There we go. That's what we want. Okay, now let's see if we can get a sound. There you go. On the speaker, it's really loud, actually. So that's perfect. Okay, I'll turn it down. All right, good. Okay, so now we know that our 4 sounds are working. Okay, and we will keep them in the background there because we need to remember what our sounds are. Okay, so let's go back to our coding here. All right, so we need to go to mu, and we're going to have to type everything, of course, because we're going to be working with it in one window and in another window. Okay, so let me go ahead and get this set up. There we go. And I'll zoom out a little bit here. Okay. So we need to go ahead and switch back to mu. Okay. We did call it doormat when we hit save. So basically, and I told you I still have a little bit of stuff here that still says Python on, the whoopee cushion on it. All right, so let's go ahead, and we want to type in the following code. Basically, this is importing the different libraries. Okay, it's importing our operating system. It's importing the random. Okay, it's importing from time library sleep. It's also importing the GPIO 0 for library, and it's called buttons. And make sure this is a capital B. Okay, so let's erase what's there. So import OS. Import random from time import sleep from GPIO 0 import capital B. Okay. And it tries to give us little suggestions to kind of walk us through what we're doing. Whoop. This part of the code pulls in all the libraries that you're going to use to write your program. Then you'll need to use the button class in your code. You'll have to tell it that the button is on pin 2. Remember GP2? That's what we did. To do this, write the following code. Lowercase b, button equals capital B. So I'd have many students and myself as well. And I even have the chart that says first attempt in learning is fails, F-A-I-L. So we just have to remember that. Okay, now let's go ahead and let's look. Now I know we're not going to be doing toots, so let's rename it sounds. So I'm going to do that in our code down here. Instead of trumps, it will be, or toots, sounds. All right, so let me look and make sure what our 4 files are called. And I'm going to upload these into the thing so y'all can download it too. So our first one is called bats. Okay. And I think that's a capital B, so I'm going to rename that because Linux can be very finicky sometimes. Okay, bats, haunted house, okay, haunted house. I will tell you this, if there's an error with it not being able to find the files, it will tell you. Laugh, howl. Okay, L-A-U-G-H-H-O-W-L. Okay. So, we need to now write our sounds. Give me 1 second here. All right, so let's go ahead and say sounds equals, and we need to have, I'm actually not sure. I know it's a bracket. Okay, no, need that bracket. It's that bracket, quote, bats, that wave, end quote, whoop, comma, quote, haunted house, comma, laugh, howl, and then close bracket. All right. I'm going to go ahead and hit save just in case. I'll hit save over here too. Why not? All right. In Python, the square brackets are used to create a list. Each item in the list is separated by a comma. Okay. You can now move on to writing the part of the program that will make something happen. When the button is pressed, begin to create a loop using while true. Make sure that that's a capital T when you type it in, okay? And this should not be a capital. There we go. Loop using while true. Add a button, wait press, inside the loop by indenting by 4 spaces, okay? Now, if we do the while true, we hit enter, it should automatically indent. It is a big deal for Python to indent, so make sure that you do have the proper indentation like below. Each time around the loop, the computer waits for the button to be pressed. Button wait for press. I'm going to follow this down here, okay? But the idea is you're kind of typing that in as we're going along here, but I'm going to go ahead and do the part here. On the next line, use random choice function to select a sound at random from a list you created earlier. That selected sound needs to be stored inside another variable which you call PARP. Type PARP equals random choice, and not trumps, it needs to be sounds. Could call it spooky sounds, but that would be extra. Okay. Next line, we'll play the sound selected at random using a play, which you used earlier to test your sound. Type OS a play format, and then we'll type all that in, okay? So let's go ahead down here, and let's type in our final code. Finally added to sleep. Pause the program before starting the loop again. So this is a good idea. So someone can only step on it with every 2 seconds or so. So we're not making a drum machine. All right, so let's go ahead and while capital true colon. Now when I actually hit enter, it's going to indent it. Boom, it's indented. Button dot wait. And those are underscores, which I wish it would show. Yeah. Wait for, and it's trying to help me, as you can see. Underscore. Press. Yeah, it gave up on that one. Button dot wait for press. Open parentheses, close parentheses. So we don't have any instructions, so we're leaving that blank. PARP equals random choice, open parentheses, sounds, close parentheses. All right. OS dot system, open parentheses, quote, a play, and we need the fancy bracket this time. And it's a 0, close fancy bracket. I don't know what that one's called actually. Dot format, open parentheses, PARP, close parentheses, and then we're going to make it sleep for 2 seconds. All right, now let's go back and check our code. I'm going to go ahead and hit save. So we have import OS, import random, from time, import sleep, from GPIO 0, import button, button, oh, hang on, button equals button. Oh, I've totally forgot to put the 2 on there. 2, always got to check your code. And I have a lot of that with students. They'll say, oh, something's happened, it's not working. I go, okay, well, let's go back and check the code. I've had it where for whatever reason we did a new file, type the code, it would not work even though it looked perfect. We'd do a new file, retype the code, and maybe somewhere in here some extra code got in there and we couldn't see it, like too many spaces or something like that, and then it worked the second time. Okay, so sounds equals bats, haunted house, laugh, howl, while true, that's a lowercase w, uppercase t, while true button, wait for press. Let's see, PAR equals random, choice sounds, OS system, a play, format, PARP. Oh, it needs a double quotes. I mean, double close parentheses. All right, so save. And then sleep 2. Okay, so let's save our file. And I'm going to turn my camera on here. And save our file, and let's hit run. Hopefully no errors. Don't see any errors. And let's take our things and touch them. Uh-oh. All right, doesn't like something I've done. Let's see. It says it cannot find the WAV file. Not found, not found, not found. Okay. All right, so let's tell it to stop. All right, now I have actually saved that where I thought was the proper place. Let me go back up here. Maybe I need to save it in a different folder. Let's see, inside the code. Let's see. Ah, okay. So here we are right there. If your Raspberry Pi is connected to the internet, you need to search for the suitable sound. They need to be WAV file format to work. Files must be unzipped in the home Pi folder. Okay, so I just have them in the wrong folder. From the computer, what I did was fine. Okay, so it can't be in the mu code. Okay, so I'm going to do the drag and drop and choose more than one at a time by holding control. And I'll just drag, hopefully it'll just say copy. Drag them right there to the Pi, home Pi folder. Okay, so when I go here, there we go. So now under Pi. All right, now let's try it. What am I doing wrong? Okay, so hold on. Something's wrong with the code here. Why is it saying a play? Let me go back and check our code. Quote, a play. Did I forget something? Format. RP. Sleep OS. System. PARP equals random choice. Let's see, bats. Well, got a quote right there at the end because that's what it's going to play. Got its format. Let's see. OS system. A play. It is 0. Yep, 0. Let's see, format. ARP. Random choice sound. try one more time and see if I can figure out why that is. Why is it say, how is it adding it like it's the name of the file, which is interesting. A play. It's not called a play. Let's see. Maybe those do need. Try again. No. Let's see. A play. Okay. Well, let's go back, and I'm actually going to go to my original tutorial on this and look at it real quick. Sleep. See button 2. Yeah. Does that need a space? Is that what the deal is? Ah. Alright, see? No. Okay. Okay. Well, I have them in the Pi folder, and I also have them in the Muse folder. Oh, it moved them. Okay. I thought it needed to be there, but then it wouldn't play it before. All right. There you go. All right, so basically, that's funny. Okay, so basically there was a space I didn't have here, and my original idea that it needed to be in the same folder as the file that I had saved. So yes, so the mu code, if you're using mu, wherever you save the file is where you need to have your sound files, okay? So I saved it into home, pi, mu code, and then it worked, okay? Here, I'll do it again. That 2 seconds seems really long, by the way. Which is kind of funny. All right, so let's go ahead and let's put it all together. So we have saved our project. We've hit run on our project. It's running. Now let's go ahead and let's get our pie plate. Or plate of pie. Alright. Now we know it's working. It's always important to make sure it's working before you put everything together. Okay. And the good thing with these, you could do this, where you have it and then you push the plastic up over it, so you know that they're not just going to accidentally bump into each other, even if you extended it. But like I said, again, you could take the alligator clips and extend this cord to be longer, or connect it up to another cord. Okay, so here we are. I got it hooked up. Here someone's coming. I got it under a floor mat, a doormat. Someone steps on it. And there you go. Gotta wait 2 seconds. I might make that a second. Alright, so let's go back. I'm actually gonna make that one second, because that seems a little long. Alright. Again, the big thing is we want to make sure it's not closing the circuit all the time. All right. I do it 2 more times and that'll be it. I like it being random, so we really don't know what it's going to play. And that's it. That's our project. Now, believe it or not, if you wanted to, because the speakers are battery powered like this, you could actually get a Raspberry Pi. You have to just check your settings, but the actual rechargeable units that cell phones have, the four maybe not as much, but the 3 are older, will definitely run on that. Just make sure that it gives enough power and everything. But usually if it says it charges 2 amps, it's plenty. So you could actually have this in like a little box or something, maybe even a little shoe box, have this sticking out of it, have this charged, have the battery for that charged, and very easily you're ready, and you actually have a portable sound, sound trap. Okay. So like I said, you could come up with other ideas. Maybe let it be something that it's like a piece of metal, but of course nothing that would conduct electricity or whatever. You'd have to rig it up so that it's just the tin foil, and then when it touches, again, like that. Okay. So, very successful on our little project today. And I will go ahead, and I said I was going to post those sound effects, so let me do that already. Give me a second. I actually have to set up a folder. Let's see. Give me a minute. I'm going to upload all that. It's uploading. So any questions? All right, I want to go to Halloween sounds. Want to see. All right, so I'm going to post that there, and it'll take you to the Google Drive folder, so you can download the little sounds we did, or have, or whatever for our project. Now, I haven't done it personally, but there actually is a way that you can set it up so that the Raspberry Pi will always run a Python code, whichever one you told it. I haven't personally done that, but something like this, you may actually want to look into that, just so that you don't have to set it up. So just when you plug it in, it restarts, and then it'll do the project too. But as long as I'm on Wi-Fi like this, I can still connect to it and then tell it what I want it to play. The cool part about this was you could actually, you know, edit this all in real time, change the sounds if I want to. If you want to add more than just 3, you can do that, and you know, just kind of have fun, use it as a project and stuff. Okay, good. Good. Rachel, I'm glad you enjoyed this project. So we'll go ahead and start wrapping up class and stuff. So any other questions or anything? Raspberry Pi is a great thing to get for the kids. All right, that's it. Won't be testing that anymore for the same sounds and stuff. But yeah, so I hope you enjoyed this project. I really do. This seems even a little more fun than the whoopee cushion one, because it's something that, you know, it's a very special time. I know a lot of the times you go into the store and you see the electronic stuff and you're like, wow, that's really neat. And it's like, well, you can do a lot of that stuff yourself with the sound effects, the LEDs, and maybe even in the future, Halloween, maybe next year, we'll talk about making like an, or maybe for Christmas, we can talking about making like an LED project or something with our Raspberry Pi. That would be pretty fun. All right, so there's not any other questions. I'll go ahead and I'll actually start wrapping class up. So today we covered a lot with our Raspberry Pi project, our sound. We talked about getting our sound, figuring out which songs we want, renaming the songs, putting them on our flash drive, moving our little sounds over to our Raspberry Pi there, connecting it up, making our door mat. I wanted to do the howl one is what I was trying to do. There you go. So we actually covered a lot today. Lots of fun things with sound, and hopefully I made the instructions pretty simple. I know it's a little bit complex with our coding and stuff, and see, even I didn't put a little space in one place, so that means it didn't work. So then we learn, we try again, we check our code, okay? Just let you know that about their classes tomorrow. If you still want to sign up for the gadget help on Zoom, just call into the Grovetown Library. It's tomorrow at 11 o'clock to 1 o'clock. They'll give you a set time, and it'll be a Zoom one-on-one video chat with me trying to get everything working, whatever problems that you're having. And then tomorrow afternoon, we're going to be doing a really fun, our last Halloween class. I know, our last Halloween class for Halloween, because Halloween's coming up. Can you believe it? Can you believe it? Halloween is on Saturday. That's right. Tomorrow's the 29th. We'll be doing Let's Make a Spooky Game. Maybe we'll get some bats flying around and some ghosts and all kinds of stuff. We'll have some good times. Just a little side note, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call into the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel and everything. And don't forget, we're trying to do our subscribe drive. If we can get 100 people to subscribe to our YouTube channel, then we can get our own customized YouTube address. So, or you can search YouTube for GCHRL videos, and it'll pop right up, okay? Very glad that you joined me today. I hope you enjoyed class. All right, and one last time. Oh, I was hoping for the house one. Hold on. Give me the house. Give me the house. All right. Happy Halloween. See you guys later. Stay safe and have a great day. Bye-bye. Bye-bye. Last time. Bye-bye.